Hi everyone, in this video we are going to build stablecoin ERC20 stablecoin smart contract. We will build it from scratch, we will test it and we will deploy it on Rootstock test network. If you don't know about Rootstock network, just go to rootstock.io and you can find all the documentation you need to know as a developer. You can also learn more high level concept like PowPeg, merge mining and explore the Rootstock ecosystem and the roadmap. They have also ambassador program. You can participate and contribute to the Rootstock ecosystem. So we are going to use Foundry, a blazing fast smart contract development tool for the smart contract development here. And if you make sure you have installed Foundry in your system. If you don't know how to install, just go to book.getfoundry.sh/getting started and installation, and install it according to your system. Also make sure you have MetaMask installed in your system and add it to your browser, and add it these two networks MetaMask to your MetaMask, Rootstock mainnet and Rootstock testnet. You can see here inside my MetaMask I have added Rootstock testnet and Rootstock mainnet as well. So without further ado, let's get started and start coding and start building our smart contract. For that we are going to create a new folder or a new directory. Let's name it stables, and open it in our browser, open it in our VS Code, not a browser, on our terminal. And since we are going to use Foundry, let's initialize the Foundry project by running this command for init, and our project is initialized. We are going to use OpenZeppelin contract library to create our ERC20 stablecoin smart contract. So let's install OpenZeppelin in our project. Forge install by running this command, forge install OpenZeppelin dash contracts dash no dash commit. While it is installing, let's delete these three files: counter.t.sol, counter.sol, and inside the script counter.is.sol. And let's create a new file inside the source directory, stable uh, stable coin.sol. And you can see here our OpenZeppelin contract library is installed. Let's start writing our smart contract. For that, let's create Fagma SPDX license identifier MIT, not SMIT. We are going to use Fagma solidity 0.8.20 and start writing our contract. Let's name it contract stablecoin. We are going to use OpenZeppelin library, but before that, let's open up our terminal and create our remappings file to avoid some red lines. For that, let's run this command forge remappings.txt, and you can see here remapping.txt is generated automatically by Foundry, and here are all the remappings. And let's import ERC20 from OpenZeppelin. ERC20 from OpenZeppelin contracts, I think token ERC20, thanks to Copilot. We also need to import enable from OpenZeppelin contracts / access. I hope access right enable.sol. And let's make our smart contract as ERC20 and enable. Let's initialize the constructor, and inside that constructor let's take two parameters as our stablecoin name, string memory name, and string memory symbol, ERC20 name symbol, and also we need to call enable here, and inside that enable we need to pass message dot sender. Right, yeah, let's format our document. So yeah, let's create our function. The first function, mint function, mint, and inside that mint function let's address to uint 256 amount, and it should be public, only owner can mint, and let's call here mint function which is coming from OpenZeppelin library, and two and more. Let's pass two and amount here. If you don't know where this mint function coming from, just we have installed OpenZeppelin in our project, and you can go here, lib OpenZeppelin contracts, inside that contracts token, and ERC20 ERC20.sol, and here you can find all the contract functions we are calling: function name, symbol, decimals, total supply, balance of, transfer, allowance, approve, transfer from, transfer, update, and mint. This is the function we are calling here inside our contract. So that's it. Let's create another function burn, and let's set two parameters: address from, uint amount, thanks to copilot, public only owner, burn, and from and amount. That's it. And let's create our last function. We are going to create this is very basic stablecoin function with limited functionalities, decimals, let's not take any parameters here, public pure, and we have to override this, and we need to return uint, right? Override returns u r returns uint8, and let's return 18, right? I've misspelled here something. Let's try compiling our smart contracts. Oh, right. This one is right. Let's start compiling our contract. First make it clear, and forge build. Yeah, we successfully you can see here compile run successful. We successfully compiled our contract. Let's start writing some badass test. To write test, just go to test directory and create a new file, stablecoin test dot p dot sol. License MIT, pragma solidity 0.8.20, and also we need to import our contract, import our test from forge standard library, not from test.sol. Import test from forge standard library, test.sol. Let's contract stablecoin test is test. Let's make it test, and we need to set some state variables here. Stablecoin public stablecoin, let's make it public. Let's name it token, token, we need to create an address of public owner, address public, let's say user1, address public, let's say user2, and let's set up our function setup public, and inside that let's initialize our variables. Owner is equal to address this, user1 equal to, let's use Foundry, make addr, which is coming from Foundry, and let's name it user1 here. User2 is equal to make addr user2 thanks to copilot, and token is equal thanks to copilot. Let's say the new stablecoin, and inside that let's name it test tables or test stablecoin, and TST as a symbol, and let's start testing. What we are going to test first? Let's first test function initial state, function test initial state, and remember your function inside your function file and solidity. Always remember your function name should start with test, and always make your functions public, and assert equal, and the live site we are going to use token.name, and inside that name we are not going to pass anything, and the right side let's pass this test table coin. Yeah, and that's it. Assert equal, and the left side token dot symbol, and the right side this is the symbol we have, right? Yeah, and again we need to assert equal, I forgot to add assert equal here, and let's pass token dot decimals, and let's say 18 decimals because we are returning 18 decimals, and assert equal token dot total supply, right side let's pass 0. That's it. Let's test our contract for first function for by running this command first test, and you can see here there's this minor warning because I'm not making it view. Our first test is fast. Let's start writing more test. I'm not going to, we can write couple of more test here, but I'm just showing you how to test smart contract. I'm not going to write all the test, because if I write to all the test here, this video will be so long, and I don't want to make you bore. So let's test one. I'm going to pass just basic functionalities here. Function test one, and let's make it public, and here mm, let's say UNT 256 UNT 256 amount is equal to 1000 to power 10 to power 18. We just declared the local variables here, and let's token dot mint, and inside that mint we have to pass user1 and the amount, right? Thanks to Copilot. And token dot burn user1 and amount. I think I made something wrong here, or this is just weird code mistake. I just one more star here, and now we have to assert equal, and the left side token dot balance of token dot let's say balance of, and inside that user1, right? Thanks to Copilot. And on the right side I have to pass 0. Let's again assert equal. On the left side token dot total supply, and the right side 0. Let's format this document and test both functions by running for test, and you can see here our two test is fast. So that's it. I'm not going to write all the test here. This is the assignment for you. You can write more test here, like test transfer, test revert when non-owner means whenever no we made our functions only owner. So make sure you are adding more test here, uh, and you can also add more test here, like test revert when known owners burns and so on. So let's start writing our deployment script, and just deploy it on Rootstock network. For that, let's create new file deploy.as.sol, and inside that start writing contract, deployment script contract, MIT why this 0.8.20. We need to import stablecoin, our contract. Before that, we need to import also script from Forge standard library. Script, yes, should be capital, from Forge standard library, script.sol. I think we need also console here to print contract. Oh, it's 0 here. Contract deploy script, it's script, and let's set up our function, or the run function run here, public, and address deploy is equal to message dot sender, and let's start broadcasting our contract. VM dot start broadcast, and inside that we need to pass deployer, stablecoin, this is the contract we imported, stablecoin. Let's name it token is equal to new stablecoin. The interface we are creating, let's name it what, Rootstock stablecoin and REST. Thanks to Copilot. And let's print this on console.log. A stablecoin deployed or the token address. Here we have to pass this address of ADD address, and inside that address we need to pass this token here, right? And let's start deploying our contract. Like clear to deploy contract, make sure, and this is the most important steps you have to follow. Make sure you are adding this EVM version as a London here, and also you need to add here RPC endpoints. That is, I'm adding, let's say, Rootstock RPC equal to, I have this RPC, you can use here, or you can go to Rootstock documentation. There you can find your API keys or the RPC. You can use this, and you can use this one as well. So let's say https slash public node. I hope this one is right. Stock dot testnet dot rsk dot co. Thanks to Copilot. And if you notice, in the last video we created a .env file, but for the security purposes I haven't created a env file here. Instead of this, I am going to use my encrypted wallet. If you don't know how to create, you can use Foundry. Comes with 4 powerful components, which is Forge, Cast, Anvil, and Chisel. So you can take leverage of Cast, and you can, using Cast, you can interact with your contract. Also, we will see in next video how to interact with your smart contract. But in this video we are going to use we are going to learn how to import your wallet using Cast. So you can run this command, cast wallet, let's say import, and your private key. You can find here your private key if you go to MetaMask, and here in your account details show private key. You can put your password here, and you can import your private key, and you can paste here in terminal and followed by your name. Let's say this is your private key, and fund it. This is the account name, or your name, wallet name. And you can to see your wallet, you can run this command, cast wallet list. So you can see here my wallet, and my wallet's private key is encrypted here. So that's it. To deploy your smart contract, you need to run command. Before that, let's try again compiling our contracts, all 3 contracts, and you can see here my contract is successfully compiled with some warning. This is just minor warning, forget it or avoid it. Let's test, forge test, and you can see our 2 test is passed, which means we are good to go and deploy our smart contract on Rootstock test network. We have set up our RPC, we have done everything, and we are good to go. To deploy your smart contract, let's run this command, forge script, and what is our folder directory name? Script, and inside that we have this file, deploy.s.sol. and inside that file we have this contract deploy script, and let's say dash dash rpc url, which is what we have declared in foundry.toml rootstock rpc. Also we need to pass broadcast, or we need to broadcast the transaction. We need to pass legacy as well, dash account. What was my account name? Pandit. Also dash dash sender. Just grab the wallet address. You encrypted the private key. Copy it from here and pass this address here and hit the enter. And let's wait for some moments, and you will see your contract deployed on Rootstock test network. If you don't have faucets, just go to Rootstock faucet.rootstock.io, copy your address, paste it here, and check this box, which is I'm not robot. Get it, they will send you some RBTC to cover the gas fees, and go back to your terminal. It is asking the key store password, which you will ask while encrypting your private key. Don't forget, I'm putting my password. And you can see here transaction is pending, and it will be deployed very soon on Rootstock test network. Let's wait. uh, you can see here also I got some RBTC to test, which is not real token, but so you can see here I got some RBTC in my wallet to test smart contract and cover the gas fees. Let's wait, and it will be deployed on Rootstock test network. Meanwhile, you can go to Rootstock um, website and go to build a section, and inside the docs you can find all the documentation and tools, SDKs, and since Rootstock is EVM compatible, so you can read more about the developer tooling and infrastructure, the POBEG app, token bridge, Foundry, Hardhat, all the documentation. They have really concise and really great documentation in the ecosystem. And here we go. You can see here our contract is successfully deployed. The chain ID is 31, estimated gas prices, and estimated total gas use for the script, and the success hash, contract address, and the block. All the information you can find here. So just copy this contract address to verify indeed we deployed it on Rootstock test network or not. Go to explorer.testnet.rootstock.io and paste the address here, and you can see here our stablecoin name, Rootstock stablecoin, symbol RST, the address, and the balance which is holding the contract holding 0 RBTC, type contract, the block, and the contract type ERC20, the deployment time 2 minutes ago, and the hash of the contract, decimals, and total supply. Total supply is 0 because we didn't minted any uh, amount of total coin. So that's it. I hope this is helpful, and I'm going to create more videos. Just let me know, and I will see you in next one. Thanks for watching.